Hello, guys. Okay, so yeah, we're back again with our continuation of differentiation. And the goal of today's lesson is to learn how to differentiate a function that has been raised in overall with a rational exponent, uh, like the one which you see here on screen, a function in which it has been raised to a rational exponent. So that function can have any structure. It can be any type of function, but it must be raised by some certain exponent at the end of the day. So to deal with this or to differentiate such kind of function, there is a rule that we have to apply. And this rule, it goes as follows. So the rule, it goes as follows. So the derivative of a function f of x, which is overall raised to some power n, is given by f prime x and times f of x to the power n minus 1. So just as we have been saying, don't try and memorize these things because they will confuse you. What you just have to do is to get the message. Once everything is clear, you can start doing your differentiation. So as a demo on how to apply or to extract all the information that is there, let's look at the following example. So you're given some function, g of x, which maybe is defined as, let's start with simple functions. Let's say we have 3x cubed minus 4x minus 5 raised to the power 10. Then let's say now our goal is to find what g prime of x is. So the answer to this goes as follows. So what is g prime x? So to find g prime x, every time when you're given a function like this one in which a function is overall raised by a power, the first step that you do is you take that power and you bring it down on the side. So you take that 10 and you bring it down. Then the next thing is you enter inside the bracket. And when you enter inside the bracket, you differentiate everything that you find there. So now let's differentiate everything that we find inside the bracket. So we get 9x squared, then plus 20x to minus 6, then we close the bracket. Then after doing that, we now bring everything that we had originally. So we bring the original function, which is 10x cubed minus 4x to minus 5 to the power 10. And then from the final exponent of the original function, we subtract 1. So then what we do then overall, we get this. So that's how you differentiate a function that has been raised by a certain exponent. So every time when you have a function raised by an exponent, these are the steps. But let's try and repeat them on another different example. So let's try and look at something a bit complex. So let's say you're given y, which is square bracket ln of 4x minus 3 plus 7 plus e to 3x minus 2. And then all this is raised to the power 35. Find dy dx. So let's say you're given that, and then they say find that. So how can we calculate this? How can we calculate this? So now to calculate this is how we proceed. You see. So we want to find what is dy dx. So to find dy dx, we now know the steps. So first you take the overall exponent and you bring it down. So you take that 35 and you bring it down. And then after bringing down that 35, you now enter inside the brackets. So whatever is inside the brackets, you differentiate it. So when you differentiate inside the bracket, the first thing that you encounter is a natural log. And we now know that every time when you want to differentiate a natural log, you start by differentiating its argument. So the argument now, when you differentiate it, you will get negative 12 x to minus 4, and 7 is a 0. Then you divide by that same argument, which is 4x to minus 3 plus 7. Then we move on to the next function, which is the exponent, is the exponential function with a base e. So we know that if an exponential function has a base e, first thing you differentiate the power. So you start by differentiating there. And when you differentiate there, you get a 3 and you bring it down. And then you bring the exponential function as it is. So you get that. Then finally, what you do is you bring in next to the whole thing, the original thing that you were differentiating. So you bring 4x to minus 3 plus 7 plus e to 3x minus 2. Then the power of the function that was originally is just decreased by 1 and you get this to the power. Then this is the final answer. So this is the procedure that you follow all the time when you want to differentiate a function which has been raised by a rational exponent. So you always do that. But one last example, because there are some examples that can trick you if you're not careful or you've never seen them, how they're being done. So let's say maybe they given that y is equals to 1 over the fifth root of 4x cubed minus 5. Find dy dx. So how can you find dy dx in a problem like this one? So the first thing is we can recognize that this y that is given, it can be written as 1 over 4x cubed minus 5 all to the power 1/5. And then this can further be written as 4x cubed minus 5 to the power minus 1/5. Then now we have this thing like that. So therefore now what is dy dx? So to find dy dx, first we take the power, we bring it down, so we bring minus 1/5. And then we differentiate the interior. So when you differentiate the interior, you see you get 12x squared. Then now you take and bring in the original function that you were differentiating, but now you take the power, which is minus 1/5, and you deduct 1 from it. Simplifications then give us negative 12 over 5 x squared and 4x cubed minus 5 all to the power minus 6/5. And then that's how it goes. So yeah, this is how you differentiate any function that has been raised by a power. So that's it for today. We can end it here.